somehow next step is very important, and this is to configure the global and local planner things. Actually, there are a lot of stuff we need to change until it works. For example, you can see here that we have added this SDF file to make sure that it should work. First thing first is that somehow the repository we are using doesn't use the color information and scheme. So we need to first change our RG, R8, G8, B8, all the three channels to the RGB8. So this is the format actually we support here. So we have somehow changed this thingy here, and then comes to the topic names. Somehow we have we are using this Jinja file to generate this R200 bar. How this information is written, it's creating the same topic for depth and color, which is not entirely correct, because if we have same topic names, then it's the PX4 won't able to differentiate them into two different names, but somehow we need these two information separately for the configuration of move base. So in the end, we have changed the generic or raw image topic name to the color, and depth to the depth image raw, and information topic cloud is apparently point. So if we come here in this launch file slam.launch, so this is the main important file. It's both two different kind of mapping. So if we make localization true, which means that we already have built the map, and now we want to just avoid the obstacle and navigate around the obstacles or fly around environment. But if we set this information to false, which means that we are in process of localizing or mapping based on octo or grid occupancy or whatever slam or vslam you're using. So in our case we are using vslam. Coming down, here's the very important bit of information. This information means that we have baselink IMU. This is the IMU link for our drone, which actually tells information about quaternion and the orientation of drone. This is very important, and externally we can manage this with the help of IMU sensor information in ROS, and ROS is written. So somehow we have the author has written this customized rotor.tf, which is changing, or let's say transforming some TFs which are very necessary to run this overall structure or mapping. So once it's not written anywhere, but you have to dig down into the repository, and for some other stuff in some other launch file you need to just copy and paste it here, and this is important. The second important thing is nodelet here. Nodelet is somehow a ROS package used by RTAB map to increase the for multi-processing, parallel processing, sorry, not multi-processing but parallel processing. Somehow there are some common or shared form of nodes which are using or giving the data used by different nodes, and to run them again and again in parallel needs more consume and more power consumption. For this purpose we can just put them in nodelets to make it accessible globally. So here you can say that we have run this native ROS standalone MATLAB ROS IMU to TF, and this is very important to change the data coming from here. So we have set the fixed frame as a map. We can set it to the world or ODOM as well, but in our case we are in map. These are simple configuration then, and this is the vslam. We are using here vslam actually, and these are the vslam. This is the important bit of information that we have segregated our topics in previously in model SDF, and now we are using them here. everything works. Here's the ghost map setting. In ghost map setting, I mean, there is point cloud XYZ node, which is responsible for converting the things into the cloud. So we are good to go. Here is the move base. Here is the some of the voxel grid marker, and everything else is not very important. So in our case, we can use joystick, we can use teleop like keyboard control, WASD thingy, or we have a third option here in our case, which is Q ground control. So we have, I mean, three options here to control this. If everything is configured as per instruction, then we can actually run this again, the px launch file, and then somehow we can say slam launch. It's gonna throw some error in start because the main problem is that the synchronous timing is a little bit lower, and until it finds the complete, you know, TF synchronization, it takes some time. As you can see here, that I guess that the camera is upward, facing upward. We need to somehow figure this out. Other than that, it's now completely integrated with move base locally. You can see your DOM topic, you can see RTAB map topic, and you can see all other relevant cost map and conversion. Next thing would be to figure out the camera, and then figure out the teleop or Q-drone control to move the drone and get this map done. And we'll see how we can save this information, and then we can run locally to avoid the obstacle. Okay, great. Other than that, we can also observe the PX4 official obstacle avoidance repository, which is which works really very well if you're using ROS 1, but not it's not working if you're using ROS 2. We need some quick fix here. So this loop closure means that it's really remember the ID or area or space of occupancy. Once it's observed, it's not gonna fill or give the binary again of occupancy grid to it, because it has seen it. So yeah, great. We'll see in next tutorial more intuitive insight into it.